Uh, wow. That was horrendous. So I didn't even do anything. I was literally just programming in Shader Toy, and then it was like it just blue screened. So let's get some Stone Rebel back. So right. So a little bit of backstory, just a tiny bit. I basically set up my Windows stream, and it blue screened. And I was thinking it was just some random blue screen because of my audio, because it said something like the sound was wrong, and something was wrong with the sound system, and I booted up OBS, and then it didn't even show my webcam or anything, and then I just blue screens. I start back up and I start the stream. 40 minutes later, while we're running in Shader Toy, what happens is it just blue screens. So I'm not going back there because it's just going to blue screen again. So, and another thing I clearly don't understand is, so another thing I clearly don't understand, that is the right, let's get back to here, is I've changed nothing. We were just running on the same, thing we've been, we've been on Windows before and we've streamed and it's been fine. So I really don't know what's changed. Maybe there's been an update. I have no idea. There's nothing new plugged into the machine. Oh, that's horrendous. Hey, they're not so red. How you been? Right, so getting back to... Right, let's just do a thing where we say float, SDF, funk, right? Some funky SDF. Put in a P, position, right? Is that all we want? I guess. I don't really need that. You know what, maybe it's fine. Yeah, so we basically just want to say like D1 equal SD sphere. So on two spheres, P, so we've got -1 on the left, +1 on the right. Is that right? Yeah. Yeah, think so. Yeah, it is. It's sine norm. So we want to like put it at probably about 0.5. And then the radius that you're passing in is going to be 0.25, right? So you do that again for whatever on the right. And then you just want a box in the middle, right? So the box would just have in the middle, and its extent is probably going to be like a vec3. So it's just a bridge in the middle, right? We're just doing, and we'll just say that's like probably about 0.5. Wait. No, 0.25 makes it half. Yeah, let's just do it anyway. We can tweak it. I know it's going to be wrong. Wait, it's got to be 25, 125, 125. Something like that. So actually D3, that would be box. So if we just literally return min of D1, min of D2, D3, that ought to be good enough. So I want to remove the camera rotation, which was this, which you discovered before Windows blue screened on us, and we switched operating systems. This is very fragile to rocks. Yeah, it was. Oh, it's just horrendous. I have no idea. I think Microsoft hates me. I'm good. What about you? Yeah, not doing bad. Not doing bad. Just trying to do a stream without computers like crashing on me. Like, it's just really bad. Oh, it's called map. Okay. So we just call that map. And Bob's your uncle. Okay. I meant to only take the off the x-axis, right? But yeah, I'm not doing bad. Not doing bad. I just been chilling. Just been working out. Just been relaxing with the family. Saw my parents today. Went for a roast. Um, yeah, that's about it. About it. This should be 175, I think. That's half of one. Oh, it isn't. Yeah. Wait, what's that box? Is that's a full extent, is it? That was a half extent. Um, right, it's in local space of the object. Um, Right, I got the Dr. Pepper Zero with new branding. Doo 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 doo. That's pretty cool, to be fair. Probably will taste the same. But yeah, got one of these. RCT, welcome. Coming the last time Windows blue screened for me, except when I tried to delete the RSS process. Lesson learned. Yeah. I don't know. It's on my work PC. It's not really blue screen. It's blue screen like once or twice in like 2 years. Um. Yeah, I think I should update it and update all the software I can on it and see what happens. But yeah, it's just there's no good operating systems to just work on apparently. They've all got issues somewhere that crashes my computer. You know what it was probably? We crashed the GPU on it. We crashed the GPU driver. So it was, and then that put the stream down. So then I started it back up again by closing the OBS and opening it back up. And then that ran for 40 minutes and it was like, nah. Yeah, it's probably that. I forgot about it, to be honest. But then it did blue screen for a different reason than before when some of the sound devices. Right, so this is not what we're thinking it was because we moved the point, the sample point, and it should be moving it in local. So I'm trying to sort of offset. So I don't offset it. It's become small. Yeah, it's becoming bigger, isn't it? I'm just trying to move it to the left a bit. What am I doing that's wrong? Because I moved by one, it was to get bigger. Even smaller again. Right, how does one work this? So your sampling array. Um, yeah, so I'm meant to have a position in space, aren't I? And I subtract it. So this is the ray that comes in. Yeah, that's what I'm missing. So we're meant to have a position in space where these things are, and then you subtract it from there. So it makes it relative from that space. So you want to basically just say, well, this one is at. So we're going. Yeah, so it's meant to be like that take. P. Whatever that is meant to be. So we've made it 0, 0, 0. Does that put it in the middle of the screen? I don't know yet. Let's... let's make this massive or much bigger. Okay, it's in the middle of the screen. So to move it, we just move this to the left. So that'd be like my -1. It's the same problem again. What am I doing? Could have sworn that's how SDFs work. Because you've got like your sample point, like you're saying over here, and maybe your ratios that way. And you're taking the difference, so it's sort of relative. It's a vector that's relative from origin to. Is that the way? Yeah, these scientific functions definitely work that way. So to take from, oh. What is being passed into map? Yeah, ray origin plus t times ray direction position. Yes, it's your sample point. That's right. Yeah, maybe my subtraction was the wrong way around. Because it's take away towards that point from where it's from. That might be actually. See, if you min it, you get a union. Am I not messing up something like that? Shoot. Yeah, so the union is a min. What am I doing that is wrong? Yeah, so position take what you the position in space, right? So it's got that framed one there. If we just move, if we up that to like 4 or 5, I moved it up, right, along the Y. I'm really confused why. Yeah, moved it across the X there. Yeah, so they're all... Okay, that one's near the middle. Yeah, so we should be doing something similar like this here, right? Where we're doing that take. P take. Maybe it's too... That's obviously make it faster, isn't it? There's less checks. Op used to do like a union, basically. This is a min. And I guess it's coloring it or something like that. Giving a different shade. So that to me... Should we start with one sphere and see if that's the problem? just getting smaller. Is it because it's not in a... Yeah, I wonder if we're in the wrong sort of like scene here. This might be like an orthographic view, maybe. Maybe it's not. What is it? Where's redirection? Yeah, let's just use a different scene. Right, let's take this to the other one. So all I wanted is a test scene so I can just test this, right? So we've probably already got this stuff in here. So we should just be able to get rid of that. Place this here. In terms of vec2. So we always want to color it to like... I think it's color, I'm not sure. What's in the y coordinate? Oh no, let's put 0 or something, see what happens. Right, so let's just get rid of all this. Right. So that's moving now. Right. There we go. Let's just do something like that. There we go. So just min all of our guys. So all I care about is just that D2 or min D2, D3. Huh? There we go. Right. Now we can just build our shape that we're looking for. So yeah, we just do... Oh, what's going on? Oh yeah, because this is too big. Okay. So we're just trying to build like just simply two balls on the left and a box in the middle. And then that would mean... So let's just stop that rotation because that's a bit silly now. Ray time. Good old time. Oh, no more time for you. There we go. Excellent. That ought to be good enough. So we're about to have map function. We're just trying to build a simple shape, and then we'll use this to sort of construct a shape out of little spheres. Just some SDF function. So we're just simply looking at... So we kind of should just build this in normalize coordinates. So -1 and 1, right? So we should go back to what I was thinking about, where we say, okay, this is 0. Probably like 0.75 to the left. And the other one would be like 0.75 to the right. Then, right. So, so that make it 0.25, that would make it 1. Right, good. So this box then, something's off. I thought this was like half extent. So why then? So if we just made something sit at 0 and we give it a full, like a radius of 0.5, Yeah, that's right. So why then if we've moved it 0.5? Oh yeah, it's too far away in it. No, what's up? So that will have a, it's got a, so it's a radius of 0.5, so it has a circumference of 1. Sorry, not circumference, a diameter of 1, right? So why? Oh, no, because it's -1 to 1, isn't it? I'm getting confused. Right. Okay. That makes sense. We've actually got you know, a unit size of a width and height and depth of 2. It's -1 to 1. That's where I was getting confused. Right, so maybe this is fine. Which maybe we should make these a little bit bigger then. So that should be 0.5, 0.5, 2.5, 2.5. Okay, that's what we want, I reckon. So we just basically want like a dumbbell, right? It should show. I don't know what sort of height we want though. It should show you basically what sort of curved. Maybe we should make the balls a little bit bigger. Just a smudge. Just a smudge. We're gonna do 3. Brought them too far in, you see. Maybe it's fine where it was. Yeah, let's just take that down to about. You know what? That's probably alright. We've just seen it through the floor. So I reckon we can take this, right, and we can construct a shape out of spheres. Yeah, and then we'll render that, and then we'll get to constructing our BVH for this thing. And it'll be interesting to see it. We can just visualize that instead. So, right, I need to open my editor again. Days. CD to that workbench, please. Right. So I'm gonna go to GFX. So what we got to last stream is simply just build that. So we built a BVH viewer for a fixed. For something that's very hard coded, we hard coded these boxes manually. We wanted to try and automate it this stream. So it's all just running faster on Manjaro, right? Weird. No. So where do we construct our shape? So we sort of map, we sort of like upload. Damn it, why isn't this thing? Right, so we sort of upload our spheres. Just called the sphere, there we go. So we should probably keep some BVHs around. Let's get rid of all this sort of sphere stuff that we're doing and redo it. So anything we see sphere around. So we keep the BVH is being constructed. But I think we shall, let's do that so it's less error prone when we copy paste. There we go. So I want to, so let's run this. So we should see one sphere. There we go. So we see a sphere. Now I want to bring that lovely, this sort of like function here. And we'll get those sign distance field stuff in as well. And we're just literally just going to construct, we'll have a resolution, and we'll just loop over and just make a bunch of spheres, and we'll tune the resolution to what we want. And that this will be our test like subject, right? So we just want to be doing this inside some form of for loop. So the for loop is going to be going over the y's and the z's, right? So it'll be something like this. What are you talking about, mate? My days. This is like a politics-free zone, my friend, so I'm sorry. Massacre soldier killer. Okay. Oh, my days. Right. Anywho. So we're going... we need our SDF sphere functions, sphere and box, right? Yeah, it's horrendous. We actually don't get a lot of those, which is super nice. But they come in sometimes. Right, F32 times 3. Length, F32 times 3. Subtract. I think I've already got one of those somewhere, but there we go. There's a new one. So we did the box already. We did maybe a 2D box. But anyways, so it's a F32. Length. So that means that one is a max S. And D would be a float. Right. I'm going to subtract. Oh, no. The one above is just a regular sub. Silly me. Right. There we go, got our things. Got our utilities. So now all we need to do is put in a subtract here. We do these guys. This is now F32 times 3. Box of P, right, I need a P. We need that PP. So the P is going to be... right, so this is in normalized space. So what are we going to iterate over, right? So we're going to have some form of resolution of these balls. So we're effectively just going to do this. We're just going to put a ball down, right? And upload it to the GPU. So we only want to do that if we're inside, right? So if D is less than 0, right, then we're inside, because there's a distance to the edge of the thing, edge of the shape. We've made a shape out of 3 shapes, join them together. 3 distances from a shape, join them together, and we just say, okay, put a sphere out there if so. So this needs to be in signed norm space, right? Snorm, sign normalized. So -1 and 1. And then we need to say, okay, if that's fine, move it out of there, and then put it into this sort of world space, right? Which is going to be very hard coded. So I think what we want to do is basically just define a step, right? So we want to have like a resolution. resolution, let's call it step, right? So so you're basically saying like, oh, 1 divided by, because it's in, well, it's probably 2. 2 divided by, because it's minus 1 and 1, so it's 2. Divided by, what is the resolution? So maybe we want to say, okay, there's 100 balls, right? So that's 100 times 100 times 100, which is actually kind of a million, isn't it? Is that right? No, it's not. Is it a million? 100? What the hell was that about? Pretty sure it is, right? Yeah, it's a million, down straight. So you would have a potential of a million being displayed. That's probably not sensible for right now, is it? We've got 100 or 1,000. So let's like just do 10. 10 balls. Is that even enough? Maybe 20. So 20 times 20 times 20. 8,000. Yeah. Let's just try 20. It's a good first place to start. So we start them all off at -1. So we have like a min max. So we have a min of -1, max of +1. So here we do min for all of these guys, max for all of those guys. Then we're going to increment it by. So the step is probably going to be the sphere's diameter, and then half of that is the sphere radius. Yes, it's a max of 8,000 spheres, but we've obviously got a bunch of empty space. So it's just step divided by 2. So then what we can do with that is increment by step, step, and step. Now, we need to work out our P. So P is a vector 3, and P is going to be obviously X, Y, and Z. And then, yeah, I did some min correctly. Okay, so now how do we translate this into this? So it depends on how yeah, so that's not really the sphere radius. So the sphere radius needs to be step divided by 2, then multiplied by something. So we need to somehow scale it from this normalized sine normalized space into, so you need like a half scale, basically, right? Sine normalized into sort of some world space. So I kind of forgot what sort of, maybe times it by like 100. So it's like 200 and push it out a bit. So we should push it out a bit into the world, right? So we should probably have this thing called like scale. So, okay. S norm to world scale. And that is basically just going to be, I know we could do 100. So you want to just do like, right, X times that, oh shoot, X times that, Z and Y. And then you want to take that sort of like step divided by 2 times that scale thing, right? So this should be fine. So the one thing that we're looking for then is the Z. We just want to push it back, right? So just push it back by 100, and I don't know, see how it looks, right? So yeah, fingers crossed it doesn't blow up the computer. It blows up the computer. Whoops. But yeah, so this should hopefully build that sort of dumbbell, right? That weight, right? And then we should hopefully be able to see that on the screen. So yeah, if it's crash the stream, I'll be right back, but it should be fine, right? We're throwing more balls at this system, so let's see how this goes. Why do you need that shape? So we want to test. We're building a BVH, right? So I want I want a shape that has a bit of flatness to it, but also a shape which has a bit of curveness to it. So I just basically did the simplest thing and just I could think of is just construct something out of basic primitives and just do some form of like, just, you know, we've got this sort of flatness here, and we've also got the curveness here. So we're making it out of loads of tiny balls. Oh, not tiny balls. I think there's only 20 going across or something dumb like that. Yeah, we'll see how it looks, and we'll increase the resolution. So, all right. Oh yeah. Boom. So now that we've got this sort of shape that we're using, right? And then we see these sort of BVH boxes. We can then sort of like see how that will wrap around here. So that we can get some sort of nice animation to sort of make it so we can actually probably see this stuff. So we might want to, we can move it further away. It definitely looks like some form of like Star Wars ship right now. I'm picturing like a little, you know, spaceship right now. But yeah, it looks proper cool with the like normal, visualizing the normal. Yeah, it's hard to sometimes see what crazy stuff I'm doing sometimes. But yeah, so you know, we're just going to visualize the BVH. I think this is kind of a good position to view at, to be honest. But we should have some code that we can comment out to see it sort of move. That's for sure. So should we get a nice little like? Should we just literally wrap it around? Should we just literally make it do a loop on the x-axis, do a loop around the x, right? I think we should try that, and then you can sort of see it go away. So I think you just need to use like sine and cosine along the x and the z, right? And then you can basically use that on t. Something dumb like that. Add a sine wave. Yeah, I do like a sine. Yeah, we'll just make it jiggle. Yeah, making it jiggle is going to be another good one. But we already did that along the wire, wasn't it? Where did we do that before? It was t times. Have we got t somewhere? I think we got a bit of t. Oh no, because we did it like plus the x position, wasn't it? Yeah, x plus time. That's going to be only by 1 though. It's probably times it by like 10. Is that too much? Yeah, it's 8,000 cut out. Okay. Whoa. Now it definitely just looks like a spaceship, doesn't it? Just flying around. It works. Yeah. I definitely want to see it from a bit below though as well sometimes. So I think we need to add a way to sort of like Can make it go a bit slower. Half speed. And then we can sort of like push it back. Maybe we just push it back, we'll see. Push it back, and I maybe also want to go a little bit down, please. Yeah, we can have different viewing angles when we sort of view it and sort of analyze it, I guess. That's probably a little bit too far away. But yeah, we can have like a viewing angle. So we'll just if-def a bunch of viewing things, right? So you just be like, oh, if 0, elif, something like that, right? So you just be like, oh yeah, center position, .z, oh, we'll push you up by 100. And then the other one's like, oh yeah, we'll push you up by 150 and then move the y down by like 50 or something like that. So let's just see how that looks. Yeah, I think that's a quite good position. Because we can see, but yeah, we might want to like move it closer or something. I could, I've got these keyboard controls. Why don't we just, why don't we just do something like that? Why am I being, like, we could just do this, right? Static offset. So you literally just go if. So you need like a DT as well. But don't worry, DT can just be hard coded because I cannot be bothered. We don't really have, I don't think we've ever calculated DT yet, so we'll just do something like that. Ought to be good enough. So we just say okay, if operating system key, all right, I need to go and open up that header because I have forgotten how, it's a very long name, I can tell you that. I need my IntelliSense. There we go, it's loaded in. So keyboard, so on the virtual keyboard, that's it, virt keyboard. So that means any keyboard, because we have multiple keyboards. If virt keyboard, probably key code is pressed. So the key code is W, I'm going to say offset dot Z plus equal, I don't know, what's the sort of speed? Speed equal 10. Speed times dt. Isn't W? Oh, I've got to include my OS. No, it's fine. I can include the OS here. Right. Elif else if S was to do a negative, nice, and away we go. Y plus, so that might be the, oh my days, where's the QWERTY keyboard? It's E and Q in it, yeah. So Q, so E will go up, Q will go down. And then we do another one of them. That's for the X. And that'll be D and A. So we can apply the offset and we can then just fly it around and see, and we'll start it off at some sensible place. But yeah, we can just move it around that way. So we then just say, okay, well that is equal to itself plus the offset, right? And then let's run that. It's dead slow, I can tell you that. It's moving. And also we can make it like be like, okay, well the T goes up by 2, so you get more wobble. So let's say, okay, 100. Maybe it's a bit too fast. And it's a bunch of else ifs. So as you can tell, I'm pressing both keys and then it's like not moving. So let's just do something like that. So I can actually hold multiple keys down in 2023. And obviously it moves faster diagonal, but you know, it's my game. Yeah, it does already give some game ideas, doesn't it? We can literally just make some. Oh. No, no, no. We got GP crash. Right, don't fly near the camera. Yeah, I need to reboot quick. It was gonna happen. Right, BRB.